Hi there, folks. Today we're looking at quadratics in standard form. Standard form for a quadratic is y equals ax squared plus bx plus c. It's essentially when it's solved for y. And when you think about standard form is how we typically see these things written, all right? When we're solving quadratics, typically they're written in standard form. If we're solving by factoring in their quadratic formula. So we see this format a lot. Okay, and so when we're graphing in standard form, the thing that kind of isn't great about graphing in standard form is the one point that we absolutely need in order to be able to graph a parabola is the vertex. And the vertex is not readily available in this format. It's not like vertex form where we just have to look at it and say, oh, the vertex is this. It's not given to us. We have to do a little bit more work in order to get the vertex, okay? So y equals ax squared plus bx plus c. We're going to find the vertex in the axis of symmetry using a little formula that's given down here. And so this formula is the opposite of b over 2a, all right? This gives us the x coordinate for the vertex. And if you're familiar with your quadratic formula, you'll recognize that this is actually a piece of the quadratic formula, all right? If you think about the quadratic formula, opposite of b plus or minus the square root of b squared minus 4ac all over 2a, if you were to eliminate the square root part of the quadratic formula, thus eliminating the plus or minus, all you have left is the opposite of b, the first part, and over the 2a. And that's where this formula comes from. It's a piece of the quadratic formula. All right. If you ignore the complex pieces of the quadratic formula, everything after the plus or minus, what you're left with is opposite of b over 2a. Okay. And so this formula gives us the x value for the vertex. All right. We still have to go find the y value for the vertex by essentially just plugging that x value in, doing a piece of an xy chart. All right. And then in terms of the axis of symmetry we already know is always x equals the x value from the vertex. And so if I have the x value from the vertex, I automatically have the axis of symmetry, okay? So it's not quite as easy as what we had when we were looking at vertex form. We have to go find the vertex. We have to do a little bit more work to get the vertex, but then we can graph it the same way. We can use that a value to graph and use some pattern recognition in order to graph this parabola, okay? For example, if I look at something like this guy, the first thing I want to do is find the vertex. And again, the vertex is an ordered pair. To find the x value for the vertex, I'm going to do opposite of b over 2a. So right here, the b value is a 2. The opposite of that is a negative 2. So opposite of b over 2. And then a is right here. It's in front of the x squared. Those are 1. So now what I have is negative 2 over 2, which is a negative 1. So that's the x value for the vertex. I still need to find the y value for the vertex. And again, think of it like you're doing an xy chart here. If I was doing an XY chart, if I plugged a negative 1 in for X, I just plug it in and see what I get for Y. It gives me that ordered pair. I have a half of the ordered pair. I need to find the other half of the ordered pair. So I plug that negative 1 in. Negative 1 squared is a 1. 2 times negative 1 is a negative 2. So I end up with this. 1 minus 2 minus 3. And that looks like a negative 4. Okay? So that's the ordered pair for the vertex, negative 1, negative 4. And now the axis of symmetry is always x equals the x value from the vertex. And now I can graph this. Let's see, negative 1, negative 4 is down here. Axis of symmetry, remember I'm going to graph this as a dotted line. And the axis of symmetry is just there to help me graph a little bit, to say, hey, let me look at this thing, I can reflect points. And then from here, I just have to look at my pattern. My a value is 1, so that's the standard shape for this thing. The standard shape was over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16, and then I can reflect each of those points using the axis of symmetry. Okay? And so I get this idea of what this thing looks like. Now I just have to graph it, and make sure you graph it as a curve. It's not a V like the absolute value. You have to graph it as a curve, and that's it, okay? If you're really, really struggling with the A value, your other option here is to do an XY chart. Now here's the thing, XY charts seem like they're kind of tough, all right? And they seem like they take a lot of time, but if you already have the vertex, the XY chart's not too bad. And notice I already kind of started an XY chart. I put the vertex at the center. So I pick values around the vertex, like negative 2, like negative 3, like 0, 1, okay? And I can plug these values in, maybe something like 2. And so as I start to plug these values in here, I get a -3. Here, let's see, that's 1 plus 2 is a 3, minus that's a 0. If I plug a 2 in, that's 2 squared is 4, plus 2 times 2 is another 4, so that's 8, minus 3 is a 5. And then going the other way, if I plug the -2 in, I get a -3 if I'm really careful. If I plug the -3 in, I get a 0 if I'm really careful. And here's the thing, I didn't actually plug those in. Remember, parabolas are symmetrical. That's why we have the axis of symmetry. So around this vertex, these values are symmetrical as well. So really, I didn't need these at all. I only need to plug values in on one side of the vertex, and then I can use my axis of symmetry. And so my point here is, as we start to look at the XY chart, you can really narrow it down. You don't have to do that many points. I already have the vertex. I already have 1 point. Do 2 or 3 more, and all of a sudden we can reflect those and graph the parabola, okay? And so I can see these points graphed here. There it is, 0, -3, 1, 0, 2, 5. That's enough, and I can reflect these points over on the other side to draw the rest of this parabola, okay? If we look at something like this guy, again, I want to find the vertex opposite of b over 2a. And so again, right here, this is a, b is a -1, c is that -4, okay? So opposite of b is going to be a +1 this time, over 2 times a, which is a 1/4 this time. And so that's 1 over 2 times 1/4 is a 1/2. And now from here, 1 divided by 1/2. Students really struggle when we divide by fractions. But think about how many halves are in one whole. That's what it's asking. 1 divided into halves. How many halves do you get? And the answer is 2. Okay, if you think that from the holistic perspective. But really, you could just say, hey, divided by 1/2 is the same as multiplying by the reciprocal, multiplying by 2. So that's a 2. Just be careful with the fractions there. And so here I have the x value. It's like doing a piece of an XY chart. So now I plug that x value in. 2 squared is a 4, times 1/4 is a 1. Right here, that's a -2 and then a -4, so it looks like a -5. Okay? And now from here, the axis of symmetry is x equals 2. Again, if you're not sure about that a value, from here, you can just expand this XY chart, starting with your vertex. Plug in like a 3 or a 4 or a 5, okay? And we can come up with the graph of it that way and then reflect the points, all right? So if I plugged a 3 in, and you could just use your calculator, use decimals here, because this one's not going to come out very nicely. 3 squared is a 9, times 1/4 is a 2.25, and then minus the 3, and then minus the 4. You get something like a -4.75. Okay, so you don't get a point that's real nice, all right? But then the same thing with the 4. 4 squared is 16, times the 1/4 is a 4, minus 4, and then minus another 4 is a -4. That one worked out okay. If I plug the 5 in, 5 squared is a 25, times the 1/4 is a 6.25, and then minus 5, and then minus 4. And again, just do them as decimals. It doesn't make sense to sit here and leave them as fractions since you're just estimating this on a graph anyway. And so as I graph this thing, let's see, 2, -5, and it didn't take a whole lot of time to be able to do that. And now the axis of symmetry. And again, the axis of symmetry is what allows me to not have to do so many points, okay? And so now as I graph this thing, ready? 3 -4.75 is right here. 4 -4 is right here. 5 -2.75 is right here. We can kind of see this thing taking shape, and I can reflect each of those points over here. So I start to reflect these points. And if you're looking at that going, I'd like a couple more points, well, yeah, expand your XY chart a little bit, okay? But that gives me a really accurate graph. We want to have at least a couple points here to make sure this thing is accurate. But then think about it this way. I could also use the a value. Remember, the a value is 1/4. So instead of, remember, our standard pattern is over 1 up 1, over 2 up 4, over 3 up 9, over 4 up 16. I do 1/4 of all those. So over 1 up 1/4. Instead of over 2 up 4, I go up 1. Instead of over 3 up 9, I go up 1/4 of that, which is 2.25. And then over 4, instead of up 16, I go up a fourth of that, so I go up 4. Okay, see, I'm expanding this out. Now, it's find the same thing if I did the XY chart, okay? And so again, use your A value, use some ordered pairs. That was a terrible looking curve. Let me try again. And that's it. And I get a nice accurate graph with really minimal work, okay? Yes, the A value is a little bit faster, a little bit less work, okay? But it's a lot more thought, okay? If you have the vertex, you can easily do an XY chart to get the rest of these, okay? If I look at this one, once again, opposite of B over 2A. So let's see, the opposite of B is a positive 2 over 2 times A, which is a 1/2. Now a little bit of multiplication. 2 times 1/2 is a 1. 2 divided by 1 is a 2. So that's the X value for my vertex. Again, to find the Y value, it's like I'm doing a piece of an XY chart. So I plug that 2 in. 2 squared is 4 times 1/2 is a 2. And then minus 2 times this guy, minus 1. And so it looks like I get a negative 3 this time. And from here, the axis of symmetry is x equals the x value from the vertex. And now I can get to graph it. I'm going to do the A value this time. Feel free to do an XY chart if you need one. 2, negative 3 is down here. The axis of symmetry is right here. The standard shape of this thing, the pattern is over 1 up 1, over 2 up 4, over 3 up 9. Okay, it's squaring those values. I'm going to do half of each of those. So instead of over 1 up 1, I go up a half. And again, I'm always counting from the vertex. Instead of over 2 up 4, I go up 2. I go up half that amount. And again, I'm counting from the vertex. Instead of over 3 up 9, I go up half of that, so up 4.5. Again, counting from the vertex. Over 4, instead of up 16, I go up 8. Okay, and now using the axis of symmetry, I can reflect each of those points to give myself a really nice, accurate graph. And again, if you're using an XY chart, that's okay. You're doing the same thing. You're finding a couple ordered pairs and then reflecting them. Okay, so start with that X value from the vertex and then count up from there. 3, 4, 5. Plug some of those values in, and you'll come up with the same graph that I have. Okay? If I look at this one, once again, opposite of B over 2A. So the opposite of B is a positive 4 over 2 times A, which is a negative 2. Now I simplify. It gives me a negative 1. Again, that's just the X value. I have to plug it into, kind of like doing an XY chart. I have to plug it in to find the Y value. So I plug that in. Let's see. Be really careful here. Negative 1 squared is a positive 1. And then minus 4 times negative 1. It helps to write this out. All right. So now here I get negative 2 plus 4 plus 2. And that gives me a positive 4. Axis of symmetry is x equals the x value from the vertex. And now from here, I'm going to use the A value. Feel free to expand that XY chart like 0, 1, 2. All right, start plugging those values in. Just be really careful as you plug them in. Let's see, negative 1, 4. It's right here. Using the A value this time, the A value is a negative 2. All right, so again, I'm going to change the standard pattern, but this one's going to open down. So instead of over 1 up 1, I go down 2. Because I multiply it by a negative 2. Oh, sorry, I forgot to draw my axis of symmetry here. So again, counting from the vertex, instead of over 2 up 4, I go down twice that because the negative 2, so I go down 8. And I could keep trying to go over 3 up 9. I'm going to go down, down 18. It kind of takes me off my graph. So let's go ahead and reflect each of these. I get this real skinny looking parabola. Okay, it's not very wide. Okay, but again, start plugging in more values here. If you plug a 0 in here, you get a 2. All right, which is what I graphed anyway. If you plug a 1 in here, you get a negative 4, which is what I graphed anyway. All right, if you plug a 2 in there, you're going to be off the graph. Okay, so use that A value, use an XY chart, all right? So standard form, the vertex is not given, we have to find the vertex. Opposite of B over 2A gives us the X, plug it back in to get the Y. And then from there, use the A value to graph or use an XY chart. But the XY chart should be really narrowed down because you start with the vertex and work your way up from there, okay?